Welcome, my dear students. We are going to study a determination of pH using quinhydrone electrode. E. Billman introduced the quinhydrone electrode in 1921. It is a sparingly soluble redox organic system in a non-ionized form. An example of redox organic system is a mixture of hydroquinone and quinone. Quinhydrone contains equimolar amount of quinone and hydroquinone. The QH it stands for quinhydrone, Q is stands for quinone, and S2Q is stands for the hydroquinone. These two substances form a reversible oxidation reduction system which involves the hydrogen ion. It is redox type of a electrode. Quinhydrone electrode is a redox type of a electrode. Q, that is a quinone, plus twice H plus twice electron. It is reversible to S2Q, that is the hydroquinone. Means quinone C6H4O2 plus twice H plus in aqueous state plus twice electron. It gives hydroquinone C6H4OH twice. The electron represented as platinum oblique S2Q, Q, H plus aqueous, where S2Q stands for the hydroquinone and quinone respectively. Expression for the reaction quotient Q is equal to activity of S2Q upon activity of Q into A raised to 2 H plus. The potential of this electrode at 298 Kelvin is obtained by substitution in the Nernst equation. EQH is equal to E raised to 0 QH minus 0.0592 divided by 2 into log 2 base 10 activity of S2Q upon activity of Q into activity raised to 2H plus. Then EQH is equal to E raised to 0 QH minus 0.0592 divided by 2 log 2 base 10 activity of S2Q upon activity of Q plus 0.0592 upon 2 log 2 base 10 activity raised to 2H plus. Since quinone and hydroquinone are in equimolar amounts, then activity of Q is equal to activity of S2Q. Means activity of quinone is equal to activity of hydroquinone. Then term activity of S2Q upon activity of Q or activity of Q upon activity of S2Q is equal to 1. The activity ratio activity S2Q upon activity Q can be assumed to be equal to 1, and then log 2 base 10 1 is equal to 0. E quinhydrone is equal to standard potential of a quinhydrone means K e raised to 0 QH minus 0 plus 0.0592 divided by 2 log 2 base 10 activity raised to 2H plus. Activity QH is equal to E raised to 0 QH plus 0.0592 divided by 2 into 2 log activity of H plus. Then activity of H plus, the 2 comes in a multiplication. Activity raised to 2, the 2 is comes to for the multiplication 0.0592 into 2 divided by 2 to 2 cancel. Then EQH is equal to E raised to 0 QH plus 0.0592 into log 2 base 10 activity H plus. The solubility of both quinone and hydroquinone in a pure water is very small. Thus, the amounts that dissolve can be assumed to be equal. The standard potential of the quinhydrone is plus 0.6994 volt. So that E quinhydrone is equal to 0.6994 plus 0.0592 log 2 base 10 activity of H plus. Instead of 0.0592, we take 0.0596 or 0.0591 also. E quinhydrone is equal to 0.699 minus 0.0592 pH. The potential of the quinhydrone electrode changes with the activity of hydrogen ions. When the pH of a solution is to be determined by using the quinhydrone electrode, a suitable cell is set up by combining this electrode with a reference electrode. For example, the saturated calomel electrode. Construction: the electrode is set up by adding a small quantity of quinhydrone to experimental solution. Mean experimental solution first take, and then we add there the quinhydrone powder, so as to saturate it. The solution gets saturated of the quinhydrone in an experimental solution. This solution is stirred, and then an electrode of platinum is introduced for contact. The platinum strip or wire dipped into the solution having H plus ions, and the other end of this strip or wire is used for the electrical contact. It is assumed that the molar concentration of quinone and hydroquinone in acidic medium remains almost the same. In acid or the base, the potassium titration, this electrode works as the indicator electrode. The electrode can be combined with the saturated calomel electrode to form the cell potential of which can measure. In acidic medium, the cell setup in the acidic medium is the saturated calomel electrode, then salt bridge, saturated solution with quinhydrone, then platinum. Means HgL dash Hg2Cl2 solid saturated. The means the mercury, mercurous chloride. The mercurous chloride, it is a calomel. That is a commercial name of that Hg2Cl2, mercurous chloride. Then KCl saturated. Then it is a combined electrode, that is a quinhydrone, that is H plus S2Q Q, then platinum. The negative terminal is a calomel electrode, and positive terminal for that connection is a quinhydrone electrode. The EMF of a cell is equal to E quinone minus E calomel. EMF of a cell is equal to E quinone minus the EMF of a saturated calomel electrode. Then E quinhydrone electrode is equal to E raised to 0 quinhydrone, means standard potential of quinhydrone, minus 0.05916 pH minus E calomel. Then EMF of a cell is equal to 0.6994 minus 0.0592 pH minus 0.242, the calomel electrode which has the potential 0.242. Then EMF of a cell is equal to 0.4574 minus 0.0592. Then the 0.0592 pH is equal to 0.457 minus EMF of a cell. Then pH is equal to 0.457 minus EMF of a cell E cell divided by the 0.0592, means a pH that can be calculated. pH is equal to 0.457 minus E cell divided by 0.0592. In alkaline medium, the cell setup is the platinum, then saturated solution with quinhydrone and salt bridge, then saturated calomel electrode. The platinum S2Q QH plus, it is connected to negative terminal. Then the KCl saturated, then Hg2Cl2 Hg, that is the calomel, it is connected to positive electrode, that is the calomel electrode, and the quinhydrone electrode is a negative electrode. The EMF of a cell is equal to E calomel minus E quinhydrone. Then EMF of cell is equal to 0.242 minus in bracket E raised to 0 QH minus 0.0592 pH in bracket complete. Then EMF of a cell is equal to 0.242 minus in bracket 0.699 minus 0.0592 pH bracket complete. Then EMF of cell is equal to 0.242 minus 0.699 plus 0.05916 pH. Then EMF of cell is equal to minus 0.457 plus 0.0592 pH. Then EMF of cell plus 0.457 is equal to 0.0592 pH. Then EMF of cell plus 0.457 upon 0.0592 is equal to pH. Then pH is equal to EMF of cell E cell plus 0.457 divided by 0.05916. Means in alkaline medium the pH can be measured by using quinhydrone electrode. Then the merits and demerits of the electrode. Advantages and disadvantages of the quinhydrone electrode. Advantages: the electrode is easy to set up and work with. It attains the equilibrium rapidly, quickly. Thus, response in the titration is very quick. It can function satisfactorily in a highly acidic or non-aqueous solution also. The electrode can be used in presence of salts of those metals like zinc, lead, copper, calcium, tin, nickel, etc., where hydrogen electrode is not suitable or doesn't function. It has low internal resistance, rapid response, and it is highly accurate in a measurement. It can also work in the presence of some oxidizing and reducing agents. A small quantity of solution is sufficient for the measurement. It is less expensive than glass electrode. It is not too easily poisoned as hydrogen electrode. Then disadvantages of the quinhydrone electrode. The electrode can function satisfactorily only in the pH range of 1 to 8. With the solution of pH greater than 8, the activity ratio no longer remains equal to 1. Activity of S2Q upon activity of Q is not equal to 1. In alkaline solution, the solubility of the hydroquinone, it being a phenol, increases, whereas that of quinone remains unchanged. Hydroquinone is more soluble in alkaline medium, acts as a weak diabasic acid, ionizes appreciably, and also get oxidized by atmospheric oxygen to quinone at higher pH values. The electrode cannot function in the presence of oxidizing and reducing agent that can react rapidly with either hydroquinone or the quinone. The electrode possesses not appreciable but a definite salt error, the potential of the electrode being directly proportional to the salt concentration. For example, ammonium salt NH4 plus that or the natural salts. Electrode doesn't function satisfactorily if the solution contain protein or the amine compounds. That is, the protein error is found. It is not stable for a long time, especially at 30 degree and above. Thank you.